Hi, welcome back to our Honors Geometry playlist. In this video, we're going to talk about our arcs and circles. So an arc is just a part of the circle on the edge. It's not the whole circumference, but it's just part of the circumference, part of the distance around the edge of a circle. And we would identify the measure of that arc, of any arc, by looking to its central angle. What's the angle in the middle of the circle that intercepts that arc? So here I've got a central angle right in the middle, and it has its endpoints on the edge of the circle. So this central angle intercepts this minor arc, this small arc right there. It's the arc between the two endpoints of the central angle. Now, anytime you're looking at the intercepted arc, if you're looking at a minor arc, it's going to be smaller than 180. If you're looking at a major arc, that is an arc that is bigger than 180. And if it's exactly 180, then it would be a semicircle. I can tell the difference between a minor arc and a major arc or a semicircle by looking at the way that it's named. A minor arc is going to use two letters like AC or XY or BW. Two letters that represent the two endpoints of the arc. A major arc is going to use three letters and will tell you exactly what direction to go when you are identifying that arc measure. Arc length is going to be that distance along the edge of the circle. So the difference between an arc measure and an arc length is that the arc measure is the degree measure of the arc. The arc length is the distance between the two endpoints, not in degrees, but in, feet or centimeters or, meters, kilometers, inches. So arc length is a length measured in feet, inches, centimeters, kilometers. Arc measure is measured in degrees. So let's look at some examples. I've got here a circle. I know the whole circle is 360 degrees. I know this part is 110. And here I have a diameter RT. That cuts the circle into two halves. And this straight line measure is 180 degrees, which means that this must be 70. So if I wanted to find the arc measure of any of these arcs, what I would want to do is I would look at the name of the arc. So like RS has two letters, that's a minor arc. That tells me to go the shortest possible distance from R to S. And if I want to find that arc measure, it's going to be the same as that central angle. So that would be 110 degrees. When you have three letters, that means it's a major arc. It's bigger than 180. So this one here is RTS. So that tells me I'm going to start at R, I'm going to go over to T, and then I'll make my way over to S. Now, I know that I have to go in that direction because if I went this direction, that would be RST, and that wouldn't work. So here I go from R to T to S. And to find the total measure of that arc, I need to add up all the little pieces here. So this is 180, and this is 70. So in total, I went 250 degrees. RST tells me I have to go from R, and then hit S first, and then hit T. And that would be 180 degrees. So let's zoom out a little bit here. I'd like you to find the measure of each central angle x, and then the measure of the arc that it intercepts is really going to be the same measure. So all we're doing here is just finding x. So I would ask you to pause the video, do the work, unpause, and check your work. And on number 2A, that should be 80. On 2B, that should be 150. So if 2A, if this is 80 degrees, then this arc is also 80 degrees. Or if here x is 150 degrees, then the arc that it intercepts here is also 150 degrees. If you want to pause the video and try 3, I want to find these arcs, and I'll put my arc symbol above those, and then unpause and check your work. We can do that. So here I should have 90, it should be 50, and we should get 180, and then these should all be 90 degrees. And the last problem type here, if I have percents, this is when it gets a little bit tricky, because in total I want degrees, I don't want percents, I want degrees. So I have to find out what is 16% of my whole. What's 16% of 360? Or what's 20% of 360? So to find that degree measure, I would take my percent as a decimal, multiply it by 360. So this would be 72 degrees. Or if I wanted to find 16%, I would take 0.16 times 360, and I would get 57.6 degrees. And I would need to convert all of these to degrees. And then I could ask you some questions about, who likes basketball and softball? What's that arc measure? But here I just wanted you to convert between percents and degrees. So that's arc measure. Check out our arc length video on the next video here in our series.